Hello, in this video I'll go over LVM, how to make an LVM partition, how to resize it, and other neat stuff about LVM. The Logical Volume Manager allows you to create and manage the storage of your servers in a very useful manner, adding, removing, and resizing partitions on demand. Getting started with LVM can be a little confusing to newcomers, so this guide intends to show the basics in a simple manner. There are several pieces of terminology that you'll need to understand to make the best use of LVM. The most important things you must know are physical volumes. These are your physical disks or disk partitions, such as dev/sdb or dev/sdc1. These are what you'd expect. These are what you're used to using when mounting or unmounting things. Using LVM can combine multiple physical volumes into volume groups. Volume groups are comprised of real physical volumes and is the storage used to create logical volumes which you can create, resize, remove, and use. You can consider a volume group as a virtual partition which is comprised of an arbitrary number of physical volumes. Logical volumes. These are volumes that you'll ultimately end up mounting on your system. They can be added, removed, and resized on the fly. Since these are contained in the volume groups, they can be bigger than any single physical volume you might have. For example, 4 or 5 gigabyte drives can be combined into one 20 gigabyte volume group, and then you can create two 10 gigabyte logical volumes off of that volume group. Getting started. First we have to create partitions before we can start with the LVM configuration. To do that, we will first check the state of all of the drives. This command shows the state of all the drives, the partitions that are contained in each, and so forth. First off, we see the first disk contains our root system and all of the files configured in it, with the system defined as just Linux. These have 3 different partitions, each with their own use, which aren't stated here, but we can figure out if we want to. And then I have added 3 more hard drives down here, dev SDB, SDC, and SDD. Each are 8 gigabytes in size, roughly, and each do not have any partitions in them. So we'll need to create some. Running this command, we can get into the fdisk utility and start creating partitions. Once in the fdisk utility, we can enter P to print to see the current status of the drives with our changes taken into consideration. Right now, I have no changes taken into consideration yet, so it's just displaying exactly what it displayed up above. To create our new partition type, type N for new, and then select primary 1, and we hit enter because we want to tell fdisk to start at the very first sector. That's default. And since I'm going to create a partition that maps the entire drive, I'm just going to hit enter again for default. But if you wanted to create a specific size of a partition, you would type plus, and let's say you wanted to make one that was 500 megabytes. You'd enter it in like that. Or 5 gigabytes. You'd enter it in like that. But I'm just going to go with the default. Once again, hitting P, we can see a printed out version of what we've just done. I now have a new partition, SDB1, with this system type is Linux. That's the next thing we need to change. For LVM to work, we have to change the system type from Linux to Linux LVM. To do that, I'm going to type in T for type, and then we have to specify a hex code. If you're new to this, you can type in uppercase L, and it'll show you a list of all of the hex codes that we can use for the different partitions. in this class we're only focused with 82 Linux swap, 83 Linux LVM, and I believe that is all the only 3 types that we'll use in this class. So for this lesson we're going to use 8E. Using the typing P again, we can now see that our system type has been changed to Linux LVM. To write the changes to the disk on the next reboot, type W, and that's it. But I have 2 more disks in this example, so I'm going to do the same steps again. Okay, once we've made all of our steps and we're satisfied with the way our partitions look using the fdisk/cul command again, we can see all our different partitions on my 4 different drives in this example, each with 1 partition that takes up the entire drive with Linux LVM system type. So now I can restart. Okay, now that we've restarted, we can view our changes once again using the fdisk/cul command, and now we see that our changes have been persistent and we have the partitions the way we want them to. To use LVM, you'll need at least 1 partition, initialize it for use with LVM, and then include it in a volume group. Why would you do this? Well, it would let you create new partitions on the fly and make better use of your space. In this example, SDB, SDC, and SDD are all physical volumes. We'll need to initialize SDB and so on as a physical volume with the pvcreate command. And then you specify which drives you want to initialize as physical volumes. I'm going to do all of the drives besides SDA. And it's successfully created. Once we've initialized the partitions or drives, we can create a volume group which is built up of them. To do this, we would run vgcreate, the name of the group, I'm going to specify it as vg1, and then the physical volumes that should be included in this new group. I'm going to specify all of them. Dev SDB, dev SDC, and dev SDD. And now we have one volume group that has 3 physical volumes included in it. To verify our changes, we run vgscan, and it found a volume group using metadata. We'll get into that later, but it found 1 volume group, vg1. We can run vgdisplay or not. We can run vgdisplay to look at the volume group name, the format, and all of the other information about it, including the size. What we really want to do is create a logical volume which we can mount and actually use. In the future, we'll run out of space on this volume. We can resize it to gain more storage. Depending on the file system you've chosen, you can do this even on the fly. For test purposes, we'll create a small volume with the volume name test. To do that, run lvcreate /n to specify the name. I'm going to call it test // size to specify what size we want it to be. And since I have 24 gigabytes of space to use, I'm going to start off making it let's make it 18 gigabytes in size. And we're going to compose this logical volume from volume group 1. The logical volume will now be accessible via dev/vg1/test and may be formatted and mounted just like any other partition. We can go and format it with makefs.exe4/dev/vg1/test. And it's done. Now we can make a directory that we can mount this partition to. Let's do /home/test. And then we can finally mount /dev/vg1/test into home/test. And we can verify this using the mount command with no arguments. And we can see at the bottom that our logical volume is mounted on /home/test. To view information about the logical volume, we run LV display. We can see the name, which volume group it's in, the UUID, which we're not considering at the moment, who has access to it, the size, and other information about it. To extend this new volume, we'll have to unmount it first. So we run the umount command /home/test. And then to extend it, we'll use the LV extend command. /L specifies how much larger you want it to be. I'm going to add 1 gigabyte of size to it, to /dev/vg1/test. Using LV display again, we can now see that our logical volume is now 19 gigabytes in size. And we can do this either way, but after we've done this, our changes are not really usable. So to test this and to make sure that we've done this right, we need to run the e2fs command, specify the file system, and this will check for any errors. No errors. And then we do the resize to fs command. And this makes the new space that we just created usable. And now we can remount and now it's remounted successfully, and now we have 19 gigabytes of space instead of only 18. Now that we've done all this, we can now make an entry into the etc/fs tab file. I'm going to use the VI editor to edit /se/fs tab. And in this file, first it specifies what device, in this case it uses a UUID, what physical device, where it's mounted, what how it's formatted, the options that we want to specify, in this case defaults, and how Linux sees it on reboots. To add the new LVM to the fs tab file, I'll specify the location, dev vg1/test, specify where I want it to mount to, how it's formatted, the options which are defaults, and how Linux sees it across reboots. The default is 00. To test my new changes, I can use the mount -o remount command and specify the home folder, the folder that is mounted to. And if it works successfully, it'll still be mounted after running this command. We can now cd to home/test, and right now there's really nothing in it. But if we were to create a file, or as much data as we wanted to, we can create all that data, unmount the volume, resize it if we need to, do the error change commands, the error check commands, and then remount it, and it will still be in use. And this logical volume, once again, where I'm CD'd to right now, is within the 3 physical disks that I started off with, just merged into one logical volume. And that's all that I have for you guys. Thanks for watching.